Millions of independent decisions happen every second. Global consumer demand is unpredictable, and for an unfiltered supply chain, that chaos is a constant threat. To manage this, organizations rely on a structured discipline, demand planning from a supply chain perspective. The goal of demand planning is to achieve equilibrium, where available supply matches customer demand. When balanced, the first benefit is improved customer service levels, measured by OTIF deliveries. The second benefit is a drop in operational vulnerabilities, eliminating excess inventory and shelf obsolescence. This balancing act does not exist in a vacuum. It forms the foundation for a broader framework known as Sales and Operations Planning, or S&OP. Achieving this equilibrium is the method an organization uses to avoid two extremes: running out of stock or suffocating under a warehouse of unsold goods. Looking at this formal APEX standard, demand planning is defined as forecasting customer demand and aligning supply chain activities efficiently. Notice the highlighted departments. The process demands quantitative data analysis combined with cross-functional collaboration. This comparative table addresses a common professional misconception. Forecasting and demand planning are two different things. A forecast is a prediction generated by statistical models. A demand plan is the negotiated version of the truth that all departments commit to executing. Raw data alone cannot drive a supply chain. A demand plan forces the entire organization, despite competing departmental goals, to align on a single reality. To see how this consensus operates in practice, we can look at baselines across different sectors. This TET market shows the reality for fast-moving consumer goods. FMCG companies rely on demand planning to survive massive, localized event spikes driven by holidays. In retail, planners face a different challenge. They must anticipate concentrated shopping surges, like Black Friday, locking in inventory months before the season begins. Contrast that with this manufacturing line. The focus shifts to calculating the exact volume of dependent parts needed to keep operations running without interruption. Whether anticipating retail shifts or scheduling manufacturing components, operating without foresight leads to operational paralysis. Let's examine how this actually works. This text breaks down the end-to-end structure of demand planning, framing it as a sequential 5-step pipeline. Step 1 is data collection. Planners aggregate historical sales data, broader market trends, and upcoming promotional schedules. Step 2 is forecasting. Here, statistical algorithms process that data, and initial human judgment is applied to the raw numbers. Step 3 introduces the demand review. This is the intersection where sales and marketing teams introduce qualitative market adjustments to the statistical baseline. Step 4 is the consensus plan. During S&OP meetings, this adjusted forecast is cross-checked against finance targets and operations capacities. Step 5 produces the output. The debated numbers are locked in, creating the official demand plan. Skipping any step in this sequence compromises the integrity of the final numbers. The pipeline is an organizational filter. It takes external market uncertainty and distills it into an executable blueprint. This pipeline operates continuously. Demand plans are rolling, updated systematically on a weekly or monthly basis. While the statistical models consume historical data, the objective is forward-looking. The system solves for future capacity, not past performance. To govern this constant updating, we look to the core principles defined by APEX best practices, documented here. The foundational rule is the one-number plan. The entire company must operate off a single aligned forecast. Adhering to that single number requires the continuous balancing of supply and demand trade-offs between competing internal departments. These principles neutralize silos. If sales targets 10,000 units while operations plans to build 8,000, the resulting physical execution will fail. Once locked, the final demand plan triggers every downstream action across 4 core domains. First, it dictates production planning, defining the volume of product that must be manufactured. Second, it drives procurement, determining the quantities of raw materials that purchasing teams must acquire. Finally, it anchors inventory and distribution, calculating the safety stock levels required and identifying where geographically that stock must be positioned. Take away the demand plan, and these 4 pillars operate blindly. Execution becomes reactive, driving higher freight costs and systemic instability. Despite this rigorous architecture, demand planning operates under friction, driven by market uncertainty. At the technical level, data quality is a constant hurdle. Injecting poor historical inputs corrupts the statistical baseline. Then there is human friction. As noted in this APICS outline, bias from the sales department is a risk, where teams may overforecast or underforecast to influence performance targets. Marketing actions contribute as well. Localized promotions create demand spikes that can confuse future predictive models. A demand plan is a fragile instrument. Its effectiveness relies on the integrity of its data and the honesty of its contributors. To combat these vulnerabilities, the discipline is evolving. As this slide outlines, companies are moving toward integrated business planning. Planners are deploying AI and machine learning to achieve demand sensing, leveraging real-time sales data and external variables, like weather patterns, to adjust forecasts instantly. Ultimately, demand planning requires predicting data, aligning resources, and agreeing on truth. It sets the baseline for operational decisions, yielding higher service at lower costs.